In this video, we're going to talk about indexing vectors. Specifically, we're going to talk about indexing or accessing multiple positions or indices inside of a vector at once. So the main concept of indexing multiple positions at once is we provide MATLAB with a list of indices that we want to access. In this case, a list of our indices is actually going to be held inside of a vector. So we're going to be using a vector of indices to index a vector. Mind-blowing, right? So for instance, let's say I wanted to index the first index, the third index, and the fourth index of a vector. So I could tell MATLAB, hey, I want to index my vector, and then I have to give it a vector of indices that I want to access. So I said I wanted to access the first index, the third index, and the fourth index. So therefore, these are indices, and what I would get back are values. So let's say I wanted to index in or place multiple values inside of a vector. So if I had a vector that was already created, so let's say 6, 3, 2, 5. And let's say I wanted to change this vector to be 7, 3, 4, 9, right? So I want to change the first index, the third index, and the fourth index. And I want to change those respectively to a 7, 4, and a 9. And I don't want to do anything to that second index. So the way I would do that is I would say, so I want to place, so let's say, so we can think of the left-hand side of our assignment operator first. We want to access the first, the third, and the fourth elements. So we can say our vector, we want to index, we want to provide it with a list of indices. So inside of a vector, we're going to say the first index, the third index, and the fourth index. And now on the right-hand side, we have to tell MATLAB one by one which values do we want to place inside of those indices. So the first value that I want to place is the 7. So let's write this in blue. It's the 7. The second value that I want to place is the 4. And the third value that I want to place is the 9. And so one by one, MATLAB is going to place the 7 inside of the vector at the first position, the 4 inside of the vector at the third position, and the 9 inside of the vector at the fourth position. So it's very, very important that you understand that these on the right-hand side, these are values, and I'm placing them inside of my vector at indices. And so, just like what we talked about with mathematical and logical operators, as you can see here, if we're doing this one-to-one comparison, there's some rules that have to happen here. So the rule is that the number of values that I'm placing inside of my vector have to be equal to the number of spots. So I can't place, so in this case I'm placing 3 values in 3 spots, but I couldn't place 4 values in 3 spots, or I couldn't place 2 values in 3 spots. Both of those instances would error. However, what I can do is I can place 1 value inside of multiple spots. So let's say I had a vector that was 6, 10, 2, and 5, and I said something like back of 3 and 1, I want to place in a 4. All right, so this is perfectly valid because MATLAB is going to take 1 value and assign it to each of the positions. So notice here, my indices don't have to be in ascending order. Whatever order that I place them in is the order in which MATLAB is going to assign them to. And that's important when we talk about more complicated stuff later on. So after this line of code, my vector has been changed where first the third value, so let's do that, the third value, which was the 2, is now changed to a 4, and the first value, which was a 6, is now changed to a 4 as well, and the other values are not touched. So after my line of code, my vector is now this. So let's say I want to access multiple parts of a vector, create a duplicate of them, and save them inside of another variable. I can do that through indexing multiple positions. So I can have something like, let's say I had a vector that was 10, 5, 2, and 1. And let's say I wanted to create a vector that was the 10, the 5, and the 1. Okay, so I can do that by, on the right-hand side of my assignment operator, I need to indicate the vector and the positions that I want to index. So I can have vec, parentheses, and then now a vector of my indices. So the 10 is at the first position, the 5 is at the second position, and the 1 is at the fourth position. And so in this case here, I can assign that to a variable a. And so at the end of this line of code, a will be the vector 10, 5, and 1. And so it's important to note here that the order matters. If I were to do something like, let's say b is equal to vec, and instead of 1, 2, and 4, let's say I said 2, 4, and 1, MATLAB is going to go in the order of the indices that I provided. So the first index, so the first value of b will be the value that's inside of the second index of vec. So that will be 5. The second value will be whatever's inside of the fourth value, or whatever's inside of the fourth index of vec. So that'll be 1. And the third value will be whatever's inside of the first index of vec, which is 10. So the order here matters. And lastly, I can repeat values as well. So let's say I said something like c is equal to vec parentheses 3, 2, 3, 1. Okay, so in this case here, the first value inside of c will be the third value inside of vec, so that's 2. Then we're indexing the second value of vec, which is 5. Then we're indexing the third value again, which is perfectly fine, so therefore I get 2. And then lastly, we're indexing the first value, which is 10. So as we talked about before, we can use end in order to access the last element inside of our vector. So let's say I had a vector that was 10, 5, 2, 6, and I wanted to do something like this. Let's say a is equal to my vector at the positions 3 and 1, 2. All right, so now here I'm using end in order to access part of my vector. So in this case here, a will be first the third number of vec, which is 2, then end, which evaluates, so remember, end evaluates to length of whatever I'm indexing. In this case, is length. So therefore, length of vec is the same thing as 4, so that's equivalent to me indexing the fourth value. So therefore, I would have a 6, and then the first index, which is 10, and then the second index, which is 5. So end is very powerful when we use the colon operator in order to index vectors. So up until now in the video, we've been using the direct entry method to create vectors of indices. However, we can use the colon operator as well to index. So for instance, let's say I have a vector and I want to index every other number. starting at the first one. So let's do another vector here. Let's say I had my vector was 10, 5, 3, 2, 8, 7, 9. All right. So let's say I wanted to index out every other number starting at the first one. So I want the 10, the 3, the 8, and the 9. So I could manually type in, so I could say something like B is vec of the first position, the third position, the fifth position, the seventh position, right? But let's say I had a vector of like 1,000 numbers, and I still wanted to do the same thing. Directly entering those numbers would be a pain, and this is when the colon operator helps. So instead of directly entering those values, I can use the colon operator to produce this vector. So my colon operator here, I want to start at the first index, so 1, and I want to go in steps of 2 until the last number. So in this case, I can use end. So I don't need square brackets around the colon operator because it automatically produces a vector, but I could include them if I wanted to, like this. Once again, that's just redundant. And so using end in conjunction with the colon operator allows you to access multiple parts of a vector very easily. So let's say I wanted to index the first half and second halves of my vector. So if I had a vector that was 6, 5, 2, 1, the first half would be these first two numbers, and the second half would be these last two numbers. So if I just wanted to hard code that, I could say first would be my vector at the first position and the second position, and my second half would be my vector at the third position and the fourth position. But let's slowly make this more and more generic. So how else can I create this vector here? I can also have my vector using the colon operator, 1 to 2. And this second, I can do the same thing, but saying 3 to 4. All right, but once again, this is not generic enough. This only works for a vector of 4 numbers. So if our length is changing, we can use the keyword end in order to make this even more generic. So one way of doing that is the second part. The most obvious way is I could just say vec 3 to end, right? However, we still, so this one will stay constant. If we want the first half, we have to start at the first one. And this end will stay constant as well. If we want the last half, the last number will be in there. But now the question is, how do I make this number and this number more generic? So if we see here, so end once again is just the same thing as length of whatever I'm indexing. So in this case, since I have 4 numbers, end evaluates to 4. I can get 2 by dividing that number by 2. So I can take it one step further by saying vec of, or actually let's write this down here. We can take this one step further by saying vec of 1 to my end, which is 4, divided by 2. And how can I get this 3? So the second half, I don't want it to include the first half, right? So if n divided by 2 is in my first half, I don't want n divided by 2 to be in my second half. What I need to do is I need to move one step over. And so I can do that by saying my vector of n divided by 2, so that's in the first half, then add 1 to that. So now I'm in the second half. I want to go all the way until the end. So once again, in this case here, end evaluated to 4, and then 4 divided by 2 is 2. which is equivalent to saying 1 to 2. And then once again, n divided by 2. So we have 4 divided by 2, which is 2. Then we're adding 1 to it, so then we're getting 3. So then we're saying 3 to the end. So the most generic way, so once again, so this only works because we have a vector of an even number of values. Let's say my vector was 5 values. Let's say I had, a 10 here. This wouldn't work anymore because n divided by 2, my end is 5. 5 divided by 2 is 2.5. And if I try to say something like vec from 1 to 2.5, I get an error because you don't have a 2.5th position. So in order to account for this, I would have to round whatever math that I'm doing there. So the most generic way of doing this is my first half. So let's write this in blue. Okay. So my first half, I'll start at the beginning of my vector, and I'll go to the round of n divided by 2. And my second half, can't spell. My second half will start, my second half will start at the round n divided by 2 plus 1, then go to the end. So let's say I want to reverse a vector. And by reverse, I just mean have the vector flip horizontally. So if I had my vector as 10, 5, and 2, if I reverse it, I want it to become 2, 5, and 10. So essentially what I'm doing here is I'm indexing my vector backwards. So remember we talked about the order in which we provide our indices matters. So if I had this vector and I wanted to reverse it, one way of doing that is I can say I index my vector starting at the third position in this case, then the second position, then the first position. And let's say I wanted to save that inside of A. So now A will be the reverse of my original vector. However, as you can see here, this part, I'm using the direct entry method, but I could also produce this using the colon operator. So one way of doing that is I could say 3, 1. But this only works if I have 3 values. So even more generically, I can use end. So the generic way of reversing any vector is by saying, so let's say A is equal to my vector starting at the last number, going in steps, actually this would not work, right? Because I can't go from 3 to 1 in steps of positive ones. I would have to say 3 steps of negative 1 to 1. And so here, generically, I could start at n, go in steps of negative 1 down to 1. Deleting multiple parts of a vector is just setting multiple indices to empty brackets. So if I had a vector that was 6, 5, 2, 8, and I wanted to delete the first half, I could do that by saying I want to assign an empty bracket to the first half of my vector. So we talked about indexing the first half, right? So we have our vector, and the first half, I start at 1, go in steps of positive 1 to my end divided by 2. And so this works once again because I have an even number of values. And so after this line of code is run, my vector is no longer 6, 5, 2, 8. My vector is just 2 and 8. So let's go over this problem. So we have vec is equal to 1 colon 2 colon 4. Then we have A is vec of 1 colon 2 colon 4. So here, this first line of code, this produces the vector 1, then it adds 2, so it gets 3. Then it goes back, so it doesn't go past 4, right? If I try to add 2, I would get 5. That's past the ending number. So my vector is 1, 3. And so now we're on the second line of code. This colon operator is producing the same vector, 1, 3, right? So first, we're trying to index the first number of vec, which is cool, which is 1. Then we're trying to index the third number of vec. There is no third number. Vec is only 2 numbers. So therefore, we're trying to index something that does not exist. So therefore, this produces an error because this third index does not exist. It's very important that you understand the difference between an indice and a value. The value of 3 is at the second index. However, there is no third index.